Hello guys, today we are going to discuss about classification of elements in modern periodic table based on their electronic configuration. Okay, or you can say also division of elements in modern periodic table based on their electronic configuration. Okay, that is according to the electronic configuration of elements present in the modern periodic table, what are the division of elements? Okay, we shall discuss today in this video. Okay, so mainly elements in modern periodic table have been divided into 4 blocks. Okay, number 1 block is S block elements. Okay, and number 2 is P block elements, and number 3 is D block elements, and the fourth one is F block elements. Okay, the elements present in modern periodic table have been divided into these 4 block elements, that is S, P, D and F. Okay, so today we shall discuss with details of each block in this video. Okay, and along with that we shall also discuss the properties of each block elements in this video one by one. Okay, so let us start. Before that, if you are new on my channel, then please subscribe my channel and press the bell icon so that you will get notification when I shall upload my new video. Okay, so let us begin the video. So you see classification of elements in periodic table based on electronic configuration. Okay, as I have already told you, the elements present in modern periodic table have been divided into 4 blocks. Okay, number 1 is S block element, number 2 is P block element, number 3 is D block element, and number 4th one is F block element. Okay, so now we shall discuss with details of each block element one by one. Okay, so now first we shall discuss this S block element with details. Okay, so you see S block element. What is S block element? Okay, element in which the last electron enter the s orbital of their respective outermost shell are called S block element. Okay, that is the elements which last electron. So what is last electron? Last electron means the valence electron. Okay, the meaning of this term last electron means the valence electron. Okay, so the elements which valence electron enter the s orbital of the outermost shell, that element is called S block element. Okay, so this is the definition of S block element. Okay, now you see it include group 1 and group 2. Sorry, here 2 is there. 2 including helium. Okay, S block element include group 1 element and group 2. Okay, that is the group 1 element and group 2 element is S block element including helium. Why it is written helium? Because you see in the periodic table helium is present in group number 18. Okay, see helium is present in group number 18. Okay, though it is present in group number 18, but the valence electron of helium enters the s orbital. You see, the electronic configuration of helium is 1s2, that is the last electron or the valence electron enters the s orbital. That's why this helium is s block element. Okay, because the last electron or valence electron of helium enters the s orbital, and we know from the definition of s block element, the elements which last electron enters the s orbital is called s block element. Okay, so that's why helium is s block element, because the outermost electron or valence electron enters the s orbital. Okay, so all the elements of group 1 and group 2 are s block elements as well as the helium also. Okay, and again you see their outermost electronic configuration is ns12, where n stands for period number or principal quantum number, because principal quantum number gives the period number. Okay, and here s is number of subshell. Okay, and this 1 2 is number of electron. Okay, so the outermost electronic configuration of s block elements may be ns1 and ns2. Okay, clear? So now let us take one example. You see, the s block element include group 1 element, so we shall consider group 1 element first. Okay, so what are the elements of group 1? You see in the periodic table, the elements of group 1 elements is hydrogen, lithium, sodium, potassium, rubidium, cesium. Okay, these are the elements of group 1. So now we shall take lithium. Okay, if we take lithium, then you see the atomic number of lithium is 3. Okay, so here electronic configuration will be one s 2 2s1. Okay, so here you see the last valence electron enters the s orbital. Okay, this is the valence electron. Okay, and this is the principal quantum number, that is the period number. Okay, so in lithium the valence electron enters the s orbital, that's why this lithium is s block element. Okay, again now take another example, sodium. The atomic number of sodium is 11. Okay, so the electronic configuration will be 1s2 2s2 2p6 and 3s1. Okay. You see here also the valence electron of sodium is also enters in s orbital. Okay, this. Okay, and so sodium is also the s block element. Okay, now let us take example as a group 2 element. Okay, because group 2 is also s block element, so now let us consider the elements of group 2. So what are the elements of group 2? You see in the periodic table, the elements of group 2 is beryllium, magnesium, calcium, strontium, barium, radium. These are the elements of group 2. Okay, now let me take this one, beryllium. Okay, beryllium. atomic number of beryllium is 4. So the electronic configuration will be 1s2 2s2. Here also the outermost electron, that is this one, is also entered the s orbital. Okay, so that's why this beryllium is also s block element. Okay, again let me take another example, magnesium. The atomic number of magnesium is 12. Okay, so the electronic configuration will be 1s2 2s2 2p6 and 3s2. Okay, so here also the outermost electron, this one, also enters in s orbital. Okay, so that's why magnesium is also s block element. Okay, s block element is clear. So now come to the properties of s block element. Okay, what are the properties of s block elements? So you see general properties of s block elements. So number one properties is they are soft metals with low melting and boiling points. That is, s block elements are very soft, or you can say very smooth. Okay, and the s block elements have low melting point and boiling point. Okay, this is the number one property. Now number two property is they are very reactive metals. That is, s block elements can react very easily. Okay, and they react very fast. Okay, so that's why s block elements are very reactive metals. Okay, so this is the number two property. Again you see the number three property, they are good conductor of heat and electricity. Okay, so s block elements are good conductor of heat and electricity. That is, through s block elements heat and electricity can pass easily. Okay, that's why they are good conductor of heat and electricity. Okay, this is the number three property. Now you see number fourth property, they are strong reducing agent. Okay, that is, s block elements help another substance to get reduced easily. Okay, that's why s block elements are reducing agent. Okay, because this s block elements helps another substance to get reduction easily. Okay, so that's why s block elements are reducing agent. Now the last property is most of the metals except beryllium and magnesium of this block impart characteristics colors to the flame. That is, the elements of group 1 and group 2 except beryllium and magnesium impart colors to the flame. Okay, that is, if we heat the elements of group 1 and group 2 elements, that is s block elements, except beryllium and magnesium, they impart colors, okay, in their flame. Okay, that's why this is also the property of s block elements. Okay, I think s block elements is clear, and also the properties of s block elements. So in my next video we shall discuss about p block elements, d block elements and f block elements. Okay, so see you on my next video. Thank you for watching.